Physics numerical. One car moving on a straight road covers 1/3 of distance with 20 km per hour and the rest with 60 km per hour. The average speed is. Now when it covers the distance of 20 km per hour, time taken will be t1, which should be distance upon speed, that is x by 3 divided by 20, that is basically x by 60. t2 would be 2x by 3 divided by 60, which would turn out to be x by 90. Velocity, average speed, would be total distance upon total time. Total distance covered is x, total time taken is x by 60 plus x by 90. On solving this, you would get the answer as 36 km per hour. So correct answer would be option D. A particle has an initial velocity of 3i plus 4j and an acceleration of 0.4i plus 0.03j. The speed after 10 seconds is. Now v equals u plus at. So v equals u plus at. U is given as 3i plus 4j. A is 0.4i plus 0.3j into time is 10 seconds. Solving this would give you an answer of 7i plus 7j. So in terms of magnitude, your speed will be 7 root 2 units. So your correct answer here is option B, 7 root 2 units. A car moving with a speed of 40 km per hour can be stopped by applying brakes after at least 2 meters. If the same car is moving with a speed of 80 km per hour, what is the minimum stoppage distance? So S is directly proportional to U square. So I can say S1 by S2 would be equal to U1 by U2 the whole square. S1 is 2, S2 we don't know, U1 by U2 is 1 by 4, which will give us S2 as 8 meters. So the correct answer is option A, 8 meters. Question 13. A 210 meter long train is moving due north at that is acceleration at a speed of 25 meters per second. A small bird is flying due south a little above the train with a speed of 5 meters per second. The time taken by the bird to cross the train is. Relative velocity of the bird with respect to train is 25 plus 5, that is 30 meters per second, that is it gets added up. So relative velocity of the bird with respect to train is 30 meters per second. Time taken by the bird to cross the train would be total distance, that is total length of the train, that is 210, divided by the relative speed of the bird with respect to the train, that is 30, that will be 7 seconds. So your answer is option B, 7 seconds. A particle moving in a straight line covers half the distance with a speed of 3 meters per second. The other half of the distance is covered in 2 equal time intervals with a speed of 4.5 meters per second and 7.5 meters per second respectively. The average speed of the particle during the motion is very similar to what the first question that we did. Let t1 and t2 are the time taken by the particle to cover the first half and the second half distance. So t1 would be equal to x by 2 divided by 3, which is x by 6. Now in case of t2, x1 is 4.5 t2 and x2 is 7.5 t2. That is, since in case of t2, that is the rest half of the distance is covered in 2 equal time intervals at a speed of 4.5 meters per second and 7.5 meters per second. So basically x1 plus x2 would be equal to half the distance, which is covered in 4.5 t2 plus 7.5 t2. So your t2 would be equal to x by 24. So total time taken is t1 plus t2, that is x by 6 plus x by 24. So average speed will be total distance covered, that is x, divided by x by 24 plus x by 6, that is the total time. On solving this, we'll get the answer as 4 meters per second. So option A is the correct answer, that is 4 meters per second. Question 8. The MI of a ring of mass capital M and radius capital R about an axis passing through its center and perpendicular to its plane is mr square. That is option C. The next one. Two circular iron discs are of the same thickness. The diameter of A is twice that of B. The moment of inertia of A as compared to that of B is, since the diameter of one is, that is A, is twice that of B, the moment of inertia would be 4 times. The moment of inertia is proportional to the radius square. So because of the square factor, moment of inertia of A would be 4 times that of B. Next one. A body rolls down an inclined plane if its kinetic energy of rotational motion is 40% its kinetic energy of translation motion, then the body is, that is basically here it says k square by r square is equal to 0.4. So in case of a solid sphere, k square by r square is 0.4. So your correct answer is option D, solid sphere. Next question. A mass attached to a massless spring is whirled in a circular path with a constant angular velocity and its angular momentum is L. If the spring is halved, keeping the velocity same, the angular momentum is. Now angular momentum is directly proportional to r square. Spring is halved means the radius is halved. If the radius is halved, that means angular momentum will decrease by 4. That is option A would be a correct answer. If original angular momentum is L, when the spring is halved, the angular momentum would be L by 4. Next question. The MI of a disc of mass capital M and radius R about an axis passing through midway between center and circumference and perpendicular to its plane would be mr square by 2. That is option A. Next one. A torque of magnitude 400 Newton meter acting on a body of mass 4 kg which produces an acceleration of 20 radians per second square. The radius of gyration about that axis is. So here k will be, that is the radius of gyration will be A by M, that is 400. So before that, moment of inertia would be T by alpha, which is 400 Newton divided by 20, so which is 20. So K will be moment of inertia divided by M, which is root of 20 by 4, which will be approximately 2.26 meters. That is option C. Next question. Assuming that the Earth is a solid sphere of radius r and mass capital M of the Earth would be given by, so F equals G small m capital M by r square and G is equal to G capital M by r square. So from these two equations we can say capital M is G r square divided by capital G. That is option A is your right answer. Next question. If small g is acceleration due to gravity on the surface of the Earth, the gain in potential energy of an object of mass small m raised from the Earth's surface to a height equal to the radius of the Earth is. The gain in potential energy would be P2 minus P1, where P2 will be minus g small m capital M by 2r and P1 would be minus gm small m by r. That will give me minus gm small m by 2r plus minus g small m capital M by r. Solving this will give me half g capital M small m by r. This can be written as gm by 2r square into small m capital R, which can be written as 2m small g r by 2, that is small mg capital R by 2. So PE is nothing but, in this case, Your correct answer would be option B, that is mg capital R by 2. At what height from the surface of the earth the value of acceleration due to gravity will fall to half that on the surface of the earth? So your gh by is equals to r square divided by r plus h the whole square. That is, this has to be gh by g would be half equals to r square by r plus h the whole square. Solving this would give you your height to be 2625 meters. That is option A. Escape velocity from the earth is about 11.4 kilometers per second. The escape velocity from a planet having twice the radius and twice the mean density as earth is. Escape velocity formula is given as root of 2 gm by r. So, which can be written as root of 2g 4 pi by 3 r cube rho. So when you basically twice the radius and twice the mean density, so radius is twice and density is also twice, so substituting that over here, we will get the answer as 31 kilometers per second. Next question, with what velocity should a satellite be launched from a height of 600 km above the surface of the earth so as to move in a circular path? Capital G, capital M and capital R values are given. So basically, in order to move in a circular path, it has to be launched with a critical velocity, which is capital GM, R plus H. Substitute all the values, you'll get the escape velocity to be 7.5 km per second. That is option B. Question 16. If the weight of a body is 100 Newton on the surface of the earth, then its binding energy on the surface of the earth is. Binding energy would be 100 Newton multiplied by radius of the earth, that is the 100 multiplied by 6.4 into 10 raised to 6, that is 64 into 10 raised to 7 joules would be your correct answer. That is option B. Next question. With what velocity should a satellite be launched from a height of 600 kilometers above the surface of the earth so as to move in a circular path? Again, this is the same question as previous one, critical velocity formula. Answer would be 7.5 kilometers per second. That is option B. Next question. The speed of sound in oxygen at a certain temperature is 460 meters per second. The speed of sound in helium at the same temperature will be. So velocity in helium will be velocity of sound in oxygen, that is 460 multiplied by 25 by 21 into 8, which would give answer to be 1420 meters per second. That is option D would be your correct answer. Next question. Velocity of sound waves in air is 330 meters per second. For a particular sound in air, a path difference of 40 centimeters equivalent to a phase difference of 1.6 pi. The frequency of the wave is, path difference is equal to 2 pi by lambda into phase difference. That is, phase difference is equal to 2 pi by lambda path difference. So phase difference is 1.6 pi equals to 2 pi by lambda into path difference is 40. From here we will obtain lambda value as 0.5 meters. Velocity will be equal to n lambda, which will be, so from here velocity we know, lambda we know, would give us frequency as 660 Hertz. That is option C. A hospital uses an ultrasonic scanner to locate tumors in a tissue. The operating frequency of the scanner is 4.2 megahertz. The speed of sound in a tissue is 1.7 kilometers per second. The wavelength of sound in the tissue is close to. Simple formula, wavelength is equal to velocity divided by frequency. Substitute the values, you'll get 4 into 10 raised to minus 4 meters. That is option A. Fourth one, that is the next one. In a sinusoidal wave, the time period for a particular point to move from maximum displacement to zero displacement is 0.17 second. The frequency of the wave is, so time taken to move from maximum to zero displacement, that is T by 4, that is quarter of a wave. T by 4 is given as 0.17. So T will be 0.17 into 4. So frequency will be 1 upon T, which will be 1 upon 0.17 into 4. So here your answer would be 1.47 Hertz. Next question, a boat at anchor is rocked by waves whose crests are 100 meter apart and velocity is 25 meters per second. The boat bounces up once in every dash second. That is basically, you have to find the time taken. So time taken would be, wavelength is given by 100, velocity is given by 25. So frequency would be obtained, and from the frequency we can get the time period, which will come out to be 4 seconds. When the temperature of an ideal gas is increased by 600 Kelvin, the velocity of sound in the gas becomes √3 times the initial velocity in it. The initial temperature of the gas is. Now velocity is directly proportional to root of temperature. So V1 by V2 will be equal to root of T1 by T2. Using this, we can get the value of temperature, that is basically velocity 2 is √3 times velocity 1. So I will have V1 by √3 V1 will be equal to temperature of an ideal gas is increased by 600 Kelvin, that is T2 is 600, we need to find T1. So solving this would give you an answer of T1 as 300 Kelvin, which is 27 degrees Celsius. That is option B. In potentiometer, to compare the EMF of two cells by sum and difference method, the balancing lengths are found to be 230 centimeter and 50 centimeter. What is the ratio of the EMFs? So by sum and difference method, E1 by E2 will be equal to L1 by L2 divided by L1 minus L2. So here in this case 230 plus 50 divided by 230 minus 50. So it will be 14 by 9, which would be 1.56. That is option A. With resistances P and Q in the left and right gas of a meter bridge, the balance point divides the wire in the ratio 1:3. When P and Q are increased by 40, the balance points divide the wire in the ratio 3:5. The value of P and Q will be length of P divided by length of Q is equal to P by Q, which is 1 by 3. So from here I can say 3P is equal to Q. In the second case, P plus 40 divided by Q plus 40 is 3 by 5. Now Q is equal to 3P, so I can say P plus 40 divided by 3P plus 40 is equal to 3 by 5. Solving this will give you the values of P and Q. So P would come out to be 20 ohm, Q would come out to be 60 ohm. So correct answer is option C, 20 ohm and 60 ohm. A wire of resistance 16 ohm is bent into a circle and a cell of EMF 2 volt and internal resistance 1 ohm is connected between 2 points of wire, a quarter circumference apart. The current in each segment of the wire is, now current in segment 1 would be R2 by R1 plus R2 the whole I, which would be equal to 4 by 16 multiplied by V by the equivalent resistance. That is 4 by 16 multiplied by V, which is given as 2 volt, and wire has a resistance of 16. So substituting that, wire has a resistance of 16, which is divided into which is bent into a circle. So each half will have 8 ohm resistance which are in parallel. So the equivalent would be 4 ohm. So solving this would give me an answer of 1 by 8 ampere. Current in the second part will be R1 divided by R1 plus R2. Similarly, into I, which will be 12 by 16 multiplied by V by RP. Again, same thing, 12 by 16 multiplied by 2 by 4, which will give an answer of 3 by 8 ampere. So correct answer is 1 by 8 and 3 by 8 amperes. Next question. In figure AB is a potentiometer wire of length 10 meters and resistance 1 ohm. The balancing length for 2 volt potential drop is 8 meters. The EMF of the battery is. So here EMF of the battery would be equal to, that is E1 I to L1. So I would be E1 divided by rho L1, which will be equal to 2 divided by 1 by 10 into 8, which is 2.5 amperes. So I, which is equals to, so E would be basically equal to I, R plus small r plus RH will give you 2.5 multiplied by 10 plus 1 plus 0, which will be 27.5 volt. This is option C. In a meter bridge experiment, unknown resistance X and known resistance 60 ohm is connected in the left and right gap of meter bridge respectively. If the null point is obtained at 40 cm from the left end, then the unknown resistance is. So your unknown resistance is Lx by Lr multiplied by R. Lx is 40, Lr will be 60, R is given as 60, so your answer is 40 ohm. So option B is your correct answer. If the resistance across a 12 volt source is increased by 4 ohm, the current drops by 0.5 ampere. The original resistance was, initial current would be V by R, which is 12 by R. Now when the resistance increased by 4 ohm, I dash will be V by R plus 4. So we know I dash minus I is 0.5 amperes. So subtracting both of them will give us V by R plus 4 minus V by R. V by R minus V by R by 4 will be equal to 0.5 amperes. Solving this will give you value of R. So on solving this, the value of R that will be obtained will be 8 or minus 12, as R cannot be negative. Value of R will be 8 ohm. So correct answer here is option A, 8 ohm. Potentiometer across terminals of a particular battery is measured in two ways. First, the potentiometer which indicates 1.5 volt, and then with voltmeter which indicates 1.48 volts on a 2 volt scale. If the voltmeter has a resistance of 200 ohm, the internal resistance of the battery is. So internal resistance is capital R E1 minus E1 by V1 minus 1, which is 200, 1.5, 1.48 minus 1. So we'll get the value of internal resistance.